Okay, welcome everyone. Thank you for joining me here today at the Maxis Tech webinar. I'm really excited to be here. So mainly today webinar will be on navigating the enterprise data and AI landscape. I will speak for around 45 minutes and then there will be Q&A session at the end where we'll be able to address some of the questions if any, right? Okay, let's go through the agendas for today. I'll be doing a bit of an introduction and then elaborating on the promises of data and AI. I will also share my journey, challenges, and tips to navigate this space. Right, and finally, like I said, we will have Q&A. But before we start, let me first really get to know you, our audiences today. Satya, can we have the poll up? Okay, so this is just a very simple question about just seeing how much our audience's knowledge is in data and AI. Just feel free to choose an option. We'll allow maybe a minute just for everyone to fill this up. Okay. Good. I think the poll show that we actually have an audience with a very good mix of background. Some people without a lot of knowledge in the space to people who are expert in the space working with data and AI, on a daily basis. So without further ado, I'll try to cover as much ground as I can. Also not to dive into too much technical details so that for the broader audience is more understandable as well. Okay. Okay. First of all, I'll start with my introduction. Who am I? And what is Maxis? Okay. My name is En Jun. I am a machine learning engineer in Maxis today. And I did not actually start off my career in the data. Just a bit of fun fact, I was actually in the oil and gas industry working in the middle of the ocean as an offshore engineer, right? Much like the picture that's illustrated here. By the way, this image is generated by AI. So it's just a bit of a fun twist that I'm adding to this deck. But as a person, I'm a dog person who happen to love solving complex problems. Okay. In Maxis, I built and operate system that allows machine to learn from data, and I'm also leading the machine learning operation in the data and AI department. So this talk, mainly I'll be sharing on my challenges and lesson learned in my experience, and I'll offer a few battle-hardened tips to help navigate the data and AI landscape. All right. For those who do not really know Maxis, Maxis is the leading converged solution provider in Malaysia. We are commonly known for our telecommunication services, but actually we also provide a variety of high-quality digital services. Rangkaian Kita, Rangkaian Malaysia is a campaign we rolled out recently that shows Maxis' commitment towards celebrating diversity and to serve people from all walks of life. We aim to provide anytime, anywhere connection for all and the widest range of digital solution and capability in offering with round-the-clock expert support. Okay. Now that we have the introduction out of the way, let's go into the main topic. Okay. I'll briefly illustrate some of the fundamental concepts around data and AI and how it really drives value for enterprise. Okay, so we'll start with data. When we talk about data, we usually start with the 5 V's of data. The 5 V's of data are volume, value, variety, velocity, and veracity. Volume is simply the amount and size of data. We often hear big data, but how big is big, right? Actually, it's all relative to how much computing capacity you have. 20 years ago, 1 gigabyte of data is actually big. But fast forward now, we typically consider data that is in the scale of terabyte or petabyte to be big data. Okay. The next V is value. This is simply just the direct and indirect value that your data can provide. And coming next, variety is about the data types and format. Data comes in a lot of different formats. For example, we have unstructured data like images, text, to semi-structured data like JSON file, or even the structured ones, the tabular ones, in relational databases that is a bit more easy to extract. And the next two, we have velocity. Velocity is all about the speed, how fast the data move, whether it's real time or not. Are you getting your real time information, from the connectivity? So velocity is all about that, the speed of data, how quickly it comes in. And finally, veracity is about the quality and accuracy of the data. It's about how reliable a data is, whether you can trust that data or not. Okay, now we know the 5 years of data. Just let's look at the common data we have in a typical telco industry, right? Some main one we will have is like customer data, to the network data, and also the transactional data. And if you talk about the 5 Vs here, right? In Maxis, we are dealing with petabytes of data on a daily basis. That's just simply the volume. And if you talk about the values that we are providing with our data, it can be in the form of connectivity, like a user browsing the web, doing downloads, doing voice call. These are all data. And we are handling a lot of different types of data as well. For example, if we talk about customer service, we are handling like speech and as well as text, to maybe some of the other structured data like customer bill payment history, right? And if we talk about velocity, user always wanted faster speed, faster internet, right? And so velocity ties to how quickly we move our data for our user. And this makes the user experience a lot more better as well. And finally, on the veracity side, in a real world, data can be very dirty. It is crucial that we have all the checks and balances in place to make sure our data is reliable, so that when we make decisions based on our data, we can actually trust it. Okay. All right. So the big question is, we have data, but where does AI actually fits in the picture? Okay. Now consider a scenario where we are trying to do a targeting campaign for product. Traditionally, someone will go and derive the business logic, the heuristic, to narrow down like from a population of people to a targeted group of people that is likely to be interested in the product. For example, we will have business rules like selecting people who are from an age of between 15 to 30, someone who owns an iPhone, and so on, right? But there are challenges that comes with this. This someone who come up with the heuristics, this person needs to be an expert. He needs to know how to, navigate around the data. What is the proper product fit and the target group that is in mind. And also, it's very tedious and time-consuming to define the correct rules. And often, it's also very hard to get right. Okay. Just want to make it a bit more fun at the moment. I want to come up with an analogy with cats and dogs, right? Let's consider this scenario. Consider that we are trying to target dogs from a kingdom of cats and dogs. What will the rules that we'll be using to separate dogs and cats, right? So ear shape and nose size here will be a very good starting point. We are saying, the rounder the ears, the bigger the nose will be our target group. So it's very easy to separate, cats and dogs from this group, right? But let's consider a slightly different scenario. If we are trying to so from this picture, right, if you want to use the heuristic we have before, can you see any cats here based on the heuristic we set, right? For example, I can already tell with pointy ears and small nose, this Chihuahua would be the cat, or maybe this as well, right? So the heuristic that we set might not be easily applicable for all our sample size. There will be some edge cases, and we need to define more rules in order to be able to capture this targeted group correctly, right? And if we want to differentiate dog breeds instead, what other rules will we use? It will be so complicated because we have to start thinking about like maybe the fur color, the paw sizes and so on, right? So there'll be a lot of rules, and it becomes complicated for us to add so many rules on top of the basic ones we have. And this is where AI can help us very well. So instead of defining the rules, we let AI learn the pattern in a few steps. We provide label examples, right? Use the data to train a machine learning model, and then use the model to predict on unseen example. What the AI can do is that it will learn to distinguish the cat and dogs based on patterns that is not so easily set by heuristic. And if you look at the heat map here, right, we can tell that the model actually considers the facial features of the dog or cat more strongly than the rest of the body, right? Something to note is AI is not magic. The capacity for the model to learn rely a lot on the quality data, and thus a model can make mistakes too. Okay, so coming back to the first scenario, right, the original one, in an alternate universe where we are using AI to do this, right? How we will do this is we will first define the label, a positive outcome for our targeted group. For example, we would define people who have purchased the pass in the past week as our targeted group, and then we merge this label to our customer data, our customer attributes like demographic, geolocation, transaction history, and so on. And we feed this data to a model for training. And finally, the model that we train can be used to help us identify the target group that is highly likely to purchase a pass from us. Okay, and I know a lot of people are worried about, model being a black box. How can we actually tell whether the model is learning on the correct features? In 2022, actually, there is a lot of tools, open source as well, available that allows users to validate the model. To validate that the model is actually learning on the features that make sense. For example, if you're looking at churn, maybe the spending behavior, the purchasing past behavior is the affecting feature for the churn group, right? And so things like feature importance will help us really interpret our model. Okay, and what does this mean is that from the original approach where we are trying to define heuristic, we call it a deterministic approach. We're actually translating now the problem into a probabilistic one, where a cognitive system can create hypotheses and make recommendation, right? And if you really think about how fast the data volume is growing today, traditional systems that use deterministic approach and manual approaches to derive insights will not be able to cope with the data that is growing exponentially, okay? And what we propose is a cognitive system that uses AI. This system will be the key to learning patterns from data and be able to drive decisions at scale. I just want to pause here right now and maybe just showcase some of the examples of AI being used in Maxis and how it's driving business competitiveness in Maxis. Okay, AI is being used in Maxis to curate, in this first example, personalized passes and deals with a recommendation system. The deals that users see in their app are actually tailored to their user profile. This is done so by clustering certain user with similar profile and providing a product that is best liked by that user profile group. Another example on the right here is actually on the collection reminder and treatment. In this use case, we predict customers that are likely to be delinquent, where the model score will be used to curate different sort of collection reminder and also treatment for the customer. So it's a bit more of a personalized treatment for our customer. And of course, customer churn and improving sales and services, getting more subscribers to buy our products remain a core part of our Maxis business. In Maxis, we use AI model to identify customer that has a high churn risk, so we can action upon this group of users by trying to retain them, right? On the opposite end, Maxis offer a broad range of products and services. Using AI to learn pattern, we are able to identify customers that have a high propensity towards taking up certain products or services. We then work with the marketing team to focus their effort on selling a service or product to this group of customers who are likely to actually take up these products, right? And on the innovation forefront, Maxis' ambition is to always be ahead. Thus, innovation is a crucial piece to strengthen our converged solution offering. In this space, we have worked on use cases like retail analytics to contact tracing, claims qualifier that uses more advanced machine learning approaches, like computer vision, natural language processing, and graph. Actually, this image here is supposed to show a heat map that I'm not sure why it's not showing right now, but that's fine. I'm just trying to illustrate what are the use cases we have. Okay. All right. So if I illustrated well enough, Maxis actually has a very strong thought leadership in data and AI, and this is backed by the people who are driving and collaborating in it. We do not see data as it is, but for us, it is all about stitching information together. If you think about it, human cannot possibly have high-speed internet if we have not connected the dots that signal can be in forms of light and lights can be transmitted in fiber optics, right? And so the point here is data is only the beginning. Connecting the dots will create the knowledge that leads to insights. And it is wisdom that translates insights into impactful decision. And it does not stop there, right? Wisdom without action has no value. We must always take action in order to realize the value. Otherwise, it's just insights or wisdom that are not captured for value. Okay, I hope right now I have convinced you so far on why we need data and AI. The world, as we speak, is becoming more and more digitalized, right? And it is not without challenges. Enterprise collects every data point they can get, but we have to ask whether these enterprises, are we really utilizing the data effectively? How many % of the data we are just collecting, but actually it's just sitting somewhere collecting dust, right? And how can we quickly connect different information and test hypotheses in an ever-growing data environment? And lastly, even if we have data and insight, do we really know how to translate that into impactful action? Imagine you have a very fancy dashboard. The dashboard tells you a lot of KPIs, a lot of metrics. But if you only take it as a face value, but you do not, make data-driven decision based on those insights, you will not capture those values, right? And so next, I will share my thoughts and experience on how we can actually navigate the data and AI landscape. All successful digital transformation comes with a fully thought out implementation plan. The chart here was actually from a book that I really like. The book is called Competing in the Age of AI by Karim and Marco. It details the 4 stages of digital operating model transformation, right? So in your stage 1, typically that will be where any company would start. The company will start with siloed data, right? Going to stage 2 is when they actually try to demonstrate value through some pilot projects. And once those once those pilot project has shown value, then is where they will try to get investment to actually establish a data hub. And finally, the stage 4 is the AI factory, right? Which will be the end state where we want to industrialize all the AI practices so that all the decisioning, all the insight and wisdom can be done at scale. Okay. And for this, right, the digital operating model transformation is more like a general overarching approaches. There will be no specific framework because no enterprise is the same, but the journey will be different. Okay. So what we will do here is we will actually look at the individual stages separately. Okay, so in stage 1, remember this chart, right? So when we say starting with siloed data, in this typical telco data, right? When we start, actually these data are not sitting together in a place where we can just easily access every one of them from a single data system, right? What commonly we have in the industry is you have this data in silos, Okay, you will have your customer service data sitting in the contact center, maybe on-prem, right? And then you have your transactional data in a different system, and the customer data, sitting with some other system, right? So, for example, if your customer service data is in a different building, the data are siloed on a different system, and then you have your marketing campaign team that is working on the customer data, which is also in a different system. The worst thing is when the two teams does not talk, these data are in silo, we cannot tap into the rich multi-dimensionalities that the data can offer. And simply say, we are just not connecting the dots, right? You think about it, when the marketing campaign team continue to target customer that has made complaints, that are unhappy, whose their pain points is not really in the product that the marketing team is trying to target them for, it will be a counter effort. It will make the experience for a customer even worse, because they are trying to get, the company to solve one thing, but instead they are getting that company to sell them more stuff, right? And so siloed data is usually a starting point, right? We need to move to stage 2, where it usually takes time to have a few pilot projects to demonstrate values before getting the approval or not to embrace a digital transformation. Here, I will offer a very pragmatic approach to demonstrating value with pilot projects. This is very important because we want to capture the vast majority buy-in with the least amount of effort and time. So the approach here is, first, we need to start with the basic. We need to find out what are the most mundane, repetitive jobs that should be a data and AI problem. Okay. And then 2, we need to identify impactful quick wins. This means that you might be able to identify, like 20 different ideas, 20 different use cases to implement, but not all of them are worthwhile, right? We need to focus on the most impactful projects with the fastest ROI, okay? And third, when we start out the AI journey in the company, many of the stakeholders in the company have no clue what AI actually is, right? In fact, some of them might actually think AI is magic because it has been hyped up so often, right? And that AI can do everything. It does not, right? We need to manage our stakeholders' expectation. And of course, we need to educate them as well. We are not just leaving them there and say, we are doing this and that, but not involving them in the whole loop of how we are approaching the problem, okay? And 4, not all projects will be successful, especially the pilot project, because a lot of it is testing and trials and errors. We need to leverage on the one that works and learn from the one that did not. And if it did not work, right, don't really spend too much time being sad away, because every failure is a learning, right? It just teaches you not to repeat what you have done, and you know what to avoid, okay? And number 5 is important because we want to demonstrate value. This value here ultimately will be solving your stakeholders' biggest pain point, right? These values can be in the form of, better sales, revenue uplift, reduction in, your stakeholder effort to do certain things, right, etc. And we must make sure our team understand the problem correctly and is really solving the user biggest pain point, rather than building a solution that is not consistent to what the stakeholders want. Okay. And finally, once we have all these 5 steps done, the last thing is we must win key influencers buy-in and repeat it. Okay. Without key influencers buy-ins, right, we won't be able to drive cultural shift towards the data and AI vision. It is very important to get these people to agree and to drive the change with us. And often one project will not be enough. We need to keep repeating this cycle until the value is felt and demand actually start flowing in, rather than the division, the data and AI division keeps on thinking about what new problem to solve, right? And during this process, is important to keep it practical. Less is more, and do not over-engineer. because the goal is really to quickly demonstrate value and repeat until there is enough impact and buy-in to trigger the next stage of transformation. Okay. All right. So now we are at stage 3, thinking about how to transform into a data hub, right? And stage 3 is actually the biggest organizational change. This transition involves like consolidating all your data assets to a central data management system of choice. This typically also means embracing the cloud because you want it to be able to scale, easily accessible, and always available. Okay. And ultimately, the goal here is to improve data accessibility and discovery from a single source of truth. Thus, it means that there won't be any more data silo. Okay. And the picture here, if it's not straightforward enough, it just simply means this transition will involve a lot of investment because it's such a big task. And there will be resistance across the company to move towards this goal. But I think this goal is very important, and that's why we need the key influencers to be able to step in and drive this cultural change. Okay. So since it is such a big task, right, it's very important that we have all the framework and strategy, right, so that data and privacy, data security, privacy concerns are governed, and the effort to use the data to drive value is actually low. Okay, the key areas here are governance, privacy and risk, data access control, data masking and encryption, data loss prevention, data discovery and classification. All these are important topics, right? But always remember, data security, no matter what, this will be the #1 priority in our stage. And if I may provide the 4 pillars for data hub strategy, it will be the 4 Ps: people, process, platform, and partners. In the people pillar, it is important to hire the right talent and put together the correct team structure. Okay, and when we are starting out with this journey, digital operator model transformation journey, it's better to have a bit more senior people who already know the landscape well enough than to have new people who are just, hitting the wall, not really progressing fast enough to put this whole framework or whole strategy in place, right? So a lot of the hiring has to be prioritized. And not to forget the existing employees as well. We need to upskill them to be able to start driving a data culture within the enterprise itself. This is essential to accelerate the adoption of the data hub so that this group of people will self-serve a lot of the activities in terms of deriving insights from the data and championing data-driven decisions. And in the process pillar, the data governance, demand management, risk and regulation, these are just some important areas to really focus on. This will put together a structure in terms of how the data hub will operate. And the third P for platform is crucial because selecting the right platform means we are building our backbone to where our data will be stored, accessed, and also action upon. Okay. And finally, we must not forget our partners as well. As a company who is maturing in data and AI, it is important to make strategic alliances with tech partners that are more technologically savvy, or data partners that has data that complement the existing data, right? Meaning, like I said, within the company itself, you already have silos, right? And when we connect the different data, the data from different silos, we can actually create a lot of insights. Same thing when we are limited to the data within our company, we must start looking externally for data that would add value to our data, right? So that the existing data in our company that does not have value would become valuable when we merge it with something else. Okay. And here in stage 3, the company have finally done all the big transitional work, transformation, and re-architect entirely to become a data hub. Right. Now we are moving to stage 4, AI factory. AI factory will not require as much architectural exercise, and this stage is actually more focused on the operating model of combining the talents, capabilities, and processes. And the keyword is in a systemized way. Okay. The chart here shows the typical focus area in an AI factory. Model development, right, will be the brain powerhouse to find new opportunity in which the use case will be operationalized in a systematic manner to cover pipelines, model preparation, deployment, DevOps, catalogs, and governance, right? So this is basically the whole landscape of what we need in our AI factory, and all these exercises or processes are the things that will help us automate driving decision at scale. There will be two parts of this. One is the AI practices, and one is the operation practices, right? And I want to start first with AI practices. To get to AI factory, the AI practices needs to be matured with proven methodologies that is reusable. Okay, what it means reusable is that these will be modules or components such as how we interpret our models, how we do fairness and bias, how we do hypothesis testing, right? All this will be like components of codes where we can reuse it to replicate the same approaches or workflow in other use cases, right? And the reusability is the important part of the methodologies. And these components, is how it helps us is when it's reusable, we are actually avoiding individualism in how we solve the problem. And this individualism is when it can balloon up into a technical depth. Imagine if you have 10 use cases, right? And in 10 use cases, you have 10 different data scientists who are, doing or building the model slightly differently. But it's actually the same similar type of problem, the same classification models, right? There should be some way where we can standardize the approaches with a reusable component so that when a person leaves or when a person is moved to focus on another problem, right, and something happened to the original use case, someone else can go into it easily to fix the problem, right? And this is the part where I say if we are not doing the standardization right, the technical debt can grow quickly and suffocate the whole data and AI team, because then when we have 40, 50 different models, there will be times where things breaks. We will need to do a lot of the maintenance work rather than creating new use cases or new values from new use cases. Okay, so like I said, there are two parts, right? AI practices, maturing the AI practices is only half the journey. We need to focus on the operational side of it. Okay, and in software development, we have DevOps. Similarly, in machine learning, we have something called MLOps. MLOps simply means a machine learning operation. And what it means is machine learning models here needs to be continuously improved and iterate upon. Okay, the MLOps tooling space is actually very daunting. It's a very confusing place to navigate. There are just way too many tools that are specialized in one way or the other, but not covering the full spectrum, right, of what machine learning needs from end to end. Okay, so setting up the machine learning operation can be a very scary task. Thus, we really need to break down the priorities. And to prioritize, we have to begin with the most critical components, right? Think about a car. What really make a car move? What you don't need? For example, like aircon, you don't really need the aircon to have the car transporting you from A to Z. Same thing with AI Factory. When you think about AI Factory, what is the engine? For us here, in my opinion, the engine is actually the workflow or the pipeline orchestrator. And then we have the case chassis, right, which is the code repository, that put everything together. And this is also the code repository where you do code versioning and as well as a CI/CD. Okay. And the third is we have the views, right? The views is the one that actually help you move. And this, in my opinion, is the model registry and how we actually serve our models, because the models will be the one that will be taking in the data and helping us to predict and output from those data, right? And a car without steering wheel won't get us anywhere, right? So the steering, in my opinion, is the experimental platform where the data scientists will be working in. This can usually be the notebook environment they are using, or it can be Amazon SageMaker, for example, where they're doing a lot of the development work, right? And not to forget, if you're in a car, you need a seatbelt, you need a monitoring and alerting system. This will trigger you when something is failing, and as well as getting people to act on it soon enough before the problem balloon up into a bigger problem, right? And finally, data is the most crucial part. This will be the fuel for AI Factory. No matter how fancy our car is, without the data, our car will move, right? All right. Okay, so here, I'm reaching to almost my last slide here. I just want to recap on what I've said just now on the digital operating model transformation. And companies that have actually embraced this has seen unmatched competitive advantage. For example, if you look at Airbnb, right, though these companies only 12 years in operation compared to Marriott's which has been there for like many decades, right? The valuation is actually similar, and more surprisingly is when we look at the number of locations versus the employees in the company, right? The ratio is just too far away, right? For example, in Airbnb, you have 1 million locations with only 1.6 thousand employees supporting it. And Marriott, you have 4,000 hotels, but you're hiring so much more employees to be supporting those hotels, right? This might not be a fair comparison. So we look at a different example here. We have Nubank, actually from Brazil, right? It's a digital bank where the customer employee ratio is actually 20,000, right? What it means is you have one employee serving 20,000 customers. And then now we compare it with a different bank in Brazil. One of the oldest bank in the world actually is called Banco do Brasil, right? The customer served per employee ratio is only 800. So it's really, it's not even 1% of, actually, maybe it's about 5% of what Nubank actually have, right? And that margin is what creates the unmatched competitive advantage. Okay. So this will be the end of my slide. I hope that the sharing has been helpful so far. I just want to leave this note here. Data and AI is vital for any businesses to survive. System of intelligence, right, will scale and drive most decisioning autonomously in the future, and create that unmatched competitive advantage against those who are late in the game. So as enterprises, business owners, we have to start looking whether we are making progress towards, transforming our enterprise or business to be data and AI ready, right? And we don't want to really be losing out in this space. Okay, that was all my slide. I'll open the floor for any questions, and I'll start looking at the questions actually. Okay. Okay, there's this question, based on your own experience, what would be the best way to describe machine learning to non-tech savvy folks, especially in terms of how it can promote productivity and operational efficiency? Okay, so this one, I think I've addressed it in my deck with the cats and dogs example, right? Where, you know, we are trying to create so many business heuristic, but actually, by having AI to help us, we don't have to derive these logics ourselves, right? We just need to embrace AI methodologies, right, to help us look at the data and learn the patterns and show us what are the important features. Then that will really reduce a lot of effort for us to manually look at the features and deriving all this business logic. What are some popular third-party data and AI tools that we should be familiar with? Okay, to start with data and AI, start with the programming language, because that's basically the bread and butter on how you start working with AI, right? If you are a programmer, if you want to be a bit more technical, right, start learning how to code. Python will be the best programming language to start because there's a big open source community that supports it. There's a lot of different libraries that is curated towards AI, right? So start with Python. And for those that are a bit more non-technical, you just want to learn about AI, I would suggest to actually start, you know, going to a lot of start looking for materials on YouTube. Actually, everything you need to know about AI on a high level or basic level is there in YouTube, in Medium posts and all that. What you really need is the ability to search correctly, which I think everyone will be able to do so. Okay, there's an interesting question here. How can we prevent certain population from being discriminated or marginalized by AI? Yeah, this question is good because model is only as good as the data you feed into it. Okay, it means that if your data is biased, right? For example, it's learning on a lot of text or historical hiring patterns, right? That was biased against a certain demographic, your model will learn that, right? Don't expect the model to do miracles and help you handle all the bias and fairness. What we need to do is, like I mentioned earlier as well, is there are a lot of interpretability or explainable AI component that we can utilize to really dissect the model in a way that we can look at, okay, for this feature, what is the distribution of, for example, race that that gives you an output of positive versus negative, right? And we will have a threshold of tolerance about, like, okay, for this feature, I don't want my model to over, how do I say, be biased against a certain age group or race, right? There are ways you can look into it to tweak the model that way, but it's a separate topic by itself. But yeah, what I'm saying is there's a way to do it and to interpret it. Okay. Do you think SMOTE is a good tool to deal with imbalanced data? If not, what is your best approach? In Maxis, we deal a lot with imbalanced data. What we mean imbalanced data is, for example, the churn use case, you will have maybe, like for us, we have 11 million subscribers, right? And perhaps on a month-to-month basis, we only have a 1% that churn, okay? Meaning 1% that's leaving leaving our services, right? And how would you predict from 11 million, that 1 million subset of people that is highly likely to churn? So there are a lot of different data processing or handling method we can do. One way is to downsample the data to match the minority class. And another way here, the SMOD, is actually also a way to handle imbalanced data where we actually, upsample the minority class to match the majority class, or there can be something where we design it to meet in the middle, where we downsample a bit on the up majority class and upsample the minority class to match at the middle ground, right? I won't say there is a straightforward answer to whether upsampling or downsampling is definitely good or not. It's all about your data, how you do your experimentation. In certain cases, mode might be a good tool to use, but in certain cases, mode might have a negative impact towards the performance, right? So it's a lot about your use cases and how you actually evaluate it. Okay, a bit more on the higher level. This person is asking, may I know if the AI and ML landscape in Malaysia is matured, as I plan to navigate into this sector, but I've seen people commenting that this industry is not that well accepted in Malaysia, mostly used by enterprise only. Actually, I tend to disagree with that. I think Malaysia has started to really put a lot of focus on digitalizing, digital transformation ever since MCO. Actually, MCO is a trigger point for enterprises, business owners all over the world to start embracing, digital transformation. And along with digital transformation, it makes the application of using AI a lot easier. And if you want to explore a career in data science without any relevant academic qualification, you can do so, but it needs a bit more discipline. Okay, it means that you need to be focused to. Sorry, I think I'm answering a different question, but yeah, this Malaysia is actually growing into a mature space where people are using data science already, and it's not too late to actually come into it. Obviously, if you want to compare it with like countries like Singapore, US, we are a little bit far behind. But if you want to get started, there is opportunities. Okay. All right. Coming back to the question just now, I'm keen to explore a career in data science, but without any relevant academic qualification. I have been taking short courses related to data science over the years. Could you share a bit of experience on how I got into data science? Okay, I'll probably start with how I got into data science. As I said, I was an offshore engineer for actually 5.5 years in both Malaysia and Norway. And how I got into it is actually I came back to Malaysia for study. I did a master degree, Master of Data Science in University of Malaya. And that's actually how I got my first step into data science. But that wasn't enough to actually be good in data science, because a lot of the courses you find these days online or in YouTube, right, is very superficial. And especially if you're not trying to get an official academic qualification, right, you need to find curriculums that is very structured so they can follow the courses along the way. Because if you're just trying to go into YouTube and learn things, right, the information is all over the place. You'll just always be touching on basic topic. You're just scratching the surface. You won't be going or following through to understand in depth of a certain topic, right? So I would suggest tools like DataCamp or even Coursera, right? There are courses that helps you with specialization. Those will be good places to start. Okay, going to the next question. How does the AI, data, and ML team works on an operational level in Maxis? Very curious to find out about how the team works. Okay, so for this one, in Maxis, we have a Center of Excellence set up. It's called the Data and AI Center of Excellence. And how we work, right? We actually have different group of different teams. Like you say, we have the AI team. within the AI team, we have data scientists and also machine learning engineers. But outside of that team as well, under the same umbrella, we have data engineers who are more focused on getting the data and as well as maintaining and driving the data hub, as we say, so that the data are accessible and available at all time, right? And as well, we also have data insights that is driven by data analysts and as well as the business insights team. So they will be the ones that is actually fulfilling business demand in terms of building certain insights, deriving certain information, and building dashboards for reporting purposes and also for driving decisions, right? And not to forget, we also have like a data governance team. This data governance team basically look at the risk and regulation. Basically, what data we have, whether this data is a third-party one or not, and whether we have proper access control to the data we are exposing to our users within the company. And all these groups, they need to talk to each other, they need to work together. It's not like each groups are just focused on individual projects, because there are interdependencies where you need their help. For example, the data scientists will need the data engineers to be good at maintaining the data hub, to detect failures, to detect data quality issues, in order that to make sure our models will work on the data that they are maintaining, right? So it's an interworking team that has to have very proper structure in terms of how the team work, right? I'm not sure if I answered the question good enough, but on the overview, right? Those are the teams we have. These people will work with each other. We have teams that set up to work with individual business teams as well, so that the knowledge transfer is there as well. Okay. How long it took to learn machine learning with basic Python and high school math? I can't answer on high school math because I didn't start learning Python with high school math, but it wasn't too hard. If you're a logical person, right, and you think logically and critically, actually coding is not a hard thing. It's just learning about the syntax, and the rest of it is really up to how you want to solve a problem. Yeah. It's like learning a language. It's like learning English, learning Spanish, just that it's in a code format. The syntax is different, right? The only advantage to learning it when you are a logical thinker or critical thinker is that you get the concept much faster. It makes things a lot easier. Okay, maybe on the last question here, is it possible to share a successful project related to data and AI within Maxis, as well as a failed project? Let me think of an example. I'm not totally involved in that project, but I've known enough to maybe just illustrate a bit on how was it successful and how was it not successful, right? So we were building this recommendation system, and in the early days, we were still testing things out. We were not able to get the performance we need, and actually it wasn't even performing as well as the existing system we have, right? And so the critical point on how we transform the project from being a failure to it being a successful project is actually how we persist in terms of solving a problem. Because let's say if we have hit the wall the first time and we say, okay, we can't solve the problem and we give up, then definitely we won't be able to continue on iterating on top of the problem to make it successful, right? Because sometimes AI is not a straightforward project. A lot of it involves research. a lot of it involves really understanding your data, testing and trials. And with testing and trials, we would expect failures, right? And so the key to that is really when you have failures, don't give up, persist a bit more, think about how to solve it with, common sense, logical thinking. And if something does not work at that point, try something else, right? Try a different approach. Try iterating it until the point, okay, you see some progress, better performance, and you continue iterating on top of that. And if you are able to improve 1% every day, eventually you get to a point where it's satisfactory. Okay. May I know what kind of skill sets that you think is important to become a good machine learning engineers? Yeah, the machine learning engineers job scope is different from company to company. But let me set the definition here is that I think machine learning engineers is someone who helps to optimize the model, as well as putting the model in deployment, right? Meaning serving the models. So to do that, a machine learning engineers needs to be very good in terms of, system design, software development, and as well as, I would say, practicality, because ultimately when you are helping a data scientist to deploy a model or deploy a use case, right? You want to make it as lean as possible and not over-engineer anything, because efficiency, runtime, memory, all this equates cost when you're running it on the cloud, right? So we want to make it as practical as possible. It really takes an engineer to become a machine learning engineer, I would say, because a lot of it is really engineering practices. Although you will need like multiple domains of knowledge, like you need some software engineering background, you need some data scientist background, you need some DevOps backgrounds, right? And that really makes it makes it very hard to get a good machine learning engineer, because it needs a combination of these skill sets. Okay, how would you suggest a fresh graduate to get started in the data and AI field? Again, this goes back to, don't wait, start. There are a lot of resources online, right? Read about it. If you want to get your hands dirty, go ahead and learn coding, right? There are a lot of resources out there that offer, free IDE. We call IDE. IDE is a development, basically a environment where programmers or developers, they can code on it. Actually, there are some free resources like Google Colab, where you can actually code on those platforms for free. And it's very easy to get started these days, right? It's not like 10 years ago where we don't have like proper cloud infrastructures, and it's not so easy to get internet and so on, right? Now everything is easily accessible and everything is online. There's no reason not to start at all, right? Just start. What is a healthy project timeline? Okay, the project timeline depends really on the complexity of the problem, right? And it depends on a lot of other factors as well, like whether the data is ready, whether you have the correct resources, you have the proper data scientists who have the domain knowledge, right? And if you want to include like POCs in terms of validating the result and making sure that is the use case actually drive business revenue and sales conversion, right? Then you're talking a project timeline of maybe like 2 to 3 months, because you're including POCs. But otherwise, if you have the data ready, you have the model ready, actually modeling is the easy part. The real thing that takes time is framing the problem, right? you have all these data. How do you connect the dots? How do you create insights? And this is not something that will come to you naturally on day one, right? You need to really understand the data, understand the problem, understand your customer pain point to be able to frame the data model good enough to fit into the model. For me, I don't really focus on how well a model performs anymore, but really on how well we frame the problem. Okay, what is the biggest data size that you have analyzed? This one, in Maxis, we deal a lot with big data. We try not to, because the biggest data we worked on, actually, we try not to work on a data too big, because one thing, it costs a lot of runtime. We always want to try to be lean as possible, but in terms of tables that have access, it's terabytes of data easily. Yeah, we can get there. How do you foresee AI being used in future retail? Actually, for future retails, the future is already there. I mean, sort of there, right? If you think about Amazon, they have completely removed, cashiers or service personnel in the store, right? They have automated everything where from a user walking into a store to the user taking up a product from the shelf, the kiosk, to the user going out of the store, right? Everything is automated. There isn't one single human interaction, and that, I think, the future is already there. We just need to look hard enough, and I'm just very excited in terms of what other opportunities the AI space will bring into the retail. Yeah. Okay. I think no more questions. All right, I think that's it for today. Thank you very much again for joining me here today. I hope everyone has a good day.